printf commands for a while, basic print commands for a while, but let me just go over it very quickly. So if you just say print with your parenthesis, and whatever you say here will be printed, as you can easily understand. If there is a variable a which is assigned a value of 10, and if you say print the value of a is comma separated by a, it will print you 10. Or the other way to do it is you can just say, since this is a string, right? This is a string, right? You can use the plus sign, the plus operator, and convert your a into a string. This converts your a into a string, and then you can concatenate this string with this new string, or you can join these two strings. Concatenation is nothing but simply joining one string after the other string, right? Even this works. Actually, in earlier versions of Python, so what we're using right now is Python 3. So what used to do is, if I just said print a without any parentheses, it used to work. It used to work very well in previous versions of Python, like Python 2.6 and 2.7. It no more works. So if you type something like this and if it's not working, probably you should just go to the top right of your IPython notebook and check out what you're running. So we are using Python 3 here, as it's clearly explicitly mentioned here. If you're using some other version of Python, like 2.6 or something, then a command like this might just simply work. But from Python 3 onwards, you need to place your small brackets or parentheses around your print statement. So that's one major difference between Python 2 and Python 3. And since people like me who have been used to Python for a long time keep doing these simple mistakes, because we're used to a syntax like this. Having said that, now let's see how to format our output, right? Because this is very important. This is like your printf, right? In printf, what do? We can say what we want, and we can just give the parameters that we want to print here. So what is the equivalent of printf, right? So let's assume I have two variables, a equals to 10 and b equals to 20. Remember, this is a one-line assignment. We just saw assignments a while ago, right? So this, I'm assigning 10 to a and 20 to b, and in a single line, I'm doing two statements, right? So having assigned these two values, now let's assume I want to print the value of a is with some value here, the value of b is this. So if I just put curly braces here, and I can say, so this is a string, right? This is a string, and string has a function called format. Dot format. I could just say, by doing this, what happens is my a goes here and my b goes here, right? So what you get is the value of a is 10, the value of and b is 20, as you would expect. So format is the important function here that we use for formatting output. Seems so natural, right? The next thing is, let's do it slightly differently. If I want to say the value of b is, so here if you notice, as compared to here I've just left my curly braces empty. Here I'm giving values here. Here I'm giving a value of 1, I'm giving a value of 0. So whatever is inside your format, the parameters of your format, this has an index of 0 and this has an index of 1. So since I'm saying the value of b is, and within braces I'm putting 1 here, so this, the value that is there in b, which is 20, gets placed here, and the value of a, which is 10 here, as per this statement, gets put here, right? So it's not necessary that I always need to have my variables that I pass to this function, right, in the same order. I can just give it indexes. The third very interesting way, which is fun to use, is something like this. Let me just show you. Okay, so here I'm saying print hello, and in my curly braces, I'm not giving an index like this. I'm not giving 0 or 1. I'm actually putting a name. So I'm putting a variable name called name here, and again, this is another parameter. So in my format string, I can actually give things like this. I can say name equals to Satish. So then what happens is Satish gets placed here, and my greeting equals to good morning, and this gets placed here, right? This is, you can think of them as key values, right? If I mean, bluntly thinking of it. So this is the key that I'm using, and Satish is the value, and the value gets placed at the key, right? So this is a very nice and very useful form of formatting strings, which is fairly unique to Python. I think there are very few languages which let you do this. Now, the other thing here is we can combine various types of arguments. So this is again another fun part. So if I say the story of, within braces I put 0. What does 0 mean here? 0 means bill, because that's the first parameter, right? Comma, curly braces 1. What is the first parameter here? It is Manfred, right? And I'm giving a string here. I'm giving a keyword argument, right? So other here equals to Greg. So Greg will be put here. Right? So I can mix and match these various options that I have here while formatting my output. Now let's look at input. Okay, we have understood how to format our output. We've understood about simple print command. Here is a fun part. I think I'll have to run this. So let me quickly run this. And what you get here is a box. It says enter a number. Suppose if I say 1, 2, 3, 4 and enter, okay, voila, it just prints my number. So that's what the code is, right? So the input function in Python gives you the text box that we just saw, where you can enter some value and we can assign that value that we entered to a variable called num, or to any variable basically. In this case, we were assigned it to num. Right? This is the basics of a very basic input output in Python. If I say 2 plus 3, this is called an operator, and the operator is operating on 2 and 3, right? So these are called operands. These are called operands, right? This is called an operator, and both 2 and 3 are called operands. Just to get the terminology here, right? Okay. Having said that, let's go and look at a bunch of examples, right? So we have all these arithmetic operators. We'll go and see what each of them are. I would prefer to execute some of this just to show you. So imagine this is assigning 10 to x and 20 to y, and I can just say this is simple addition, as you would expect. I can of course do subtraction, very simple, straightforward. Again, of course, 10 minus 20 is minus 10. As you can see the output here. This is let me just highlight the output for you. This is where the output is, just FYI. Next, if I can of course do simple multiplication, ding dong ding, straightforward, and of course division. Of course 10 by 20 is half. Here is an interesting operation. I'll just not use the same things here. Suppose if I have 15 percentile 2, right? This is your percentage symbol. So what it does is, so for those of you who do not know what this percentage operator is, it's also called a modulo operator. What it does is, it divides 15 by 2. So 2 sevens are 14. It gives you the remainder that you get, which is 1 in this case. And that's what is the output of 15 modulo 2. It's nothing but what is the remainder that you get when you divide 15 by 2. Those of you who have some familiarity with any programming language would immediately recognize this. Okay. The next thing is a floor operator. For example, if I just say if I do double division symbol instead of using a single division symbol. Okay, let's do 15 by 2. 15 by 2 is 7.5. So what is floor? Floor basically is if I have any real value. So 15 by 2 is 7.5. Floor of 7.5. Mathematically, it's often written as this. Floor of 7.5 is basically the integer which is closest to 7.5 and less than 7.5. So on the number scale, if this is your 7.5, this is your 8, and this is your 7, the closest integer to 7.5 is 7, and it should be less than 7.5. So you get 7. That's what you got here as an output, right? This is what floor division means. Now the next interesting question is, what happens to floor division if I do minus 15 floor division 2, right? So this is interesting. This is a fun hack, because what is minus 15 by 2? Minus 15 by 2 is minus 7.5. On my number line, here is my minus 7 point, minus, of course, here is my 0, here is my minus 7, here is my minus 8, right? In floor operation, what should happen is, you should find a number, an integer, could be negative integer, which is closest to my number, but still less than this. That's why you get minus 8 and not minus 7. Right? This is important when you're doing a floor operation. So the floor of minus 7.5 is not minus 7, it's minus 8. A lot of people get this wrong. So the other interesting operation is called exponent. So what is exponent? Exponent is basically x power y. So I can represent it with 2 stars. So 2 power 4. Any guesses? 16, right? So 2 power 36, 34. This will be harder. Of course, I couldn't have guessed it. Okay, so what it's doing is it's basically computing x. So if this is x and this is y, it's doing x power y. So if you have x star star y, this is nothing but x power y, right? So we also have the exponent function, exponent operator in Python, very nicely and useful for us. Again, all these mathematical operators will come in extremely handy for us. Again, then we have all these basic logical operators. So of course, and what the output is basically Boolean. They give us Boolean outputs. For example, if I just run this snippet of code here, of course, a is 10, b is 20, and so is print a less than b. Of course, a is less than b, so it prints true here, right? We have your this is your greater than operation. This is your less than operator. This is your double equal to. Is a equal to b? This is a not equal to b, greater than equal to, and less than equal to. If you have any familiarity with a basic mathematical comparison or any programming language, this is straightforward for most of you. Having said that, let's go to logical operators, which are fun, right? So you have your logical and logical or. So what is a logical and? So let me just give you a quick table here. So true and true is true, right? True and false is false. False and false is of course false. And false and true is false, right? Similarly, what about your OR table? Your OR table is, okay, true or true is true, true or false, same, false or true, both of them are true, only false and false is false. Okay, these are your simple logical operators that you would have learned in basic logic in your high school, and exactly that's what it does. So this logical AND is exactly like double ampersand in C. Your OR is like your double line in C. Not is exactly like that. Okay, so instead of using these symbols in Python, you can just explicitly call them out with names. Next comes a very interesting topic called bitwise operators. These are a little tricky. Only computer science folks typically understand what these bitwise operators are, but they're very, very straightforward. Let's go and understand. So a equals to 10, b equals to 4. So how is 10 represented in binary representation? So a equals to 10. So what is 10? 10 is, 10 is basically, you can write it as 2 power 3 plus 2 power 1, right? So this is 8 and this is 2, so that's 10. So this is 2 power 0, 2 power 1, 2 power 2, and 2 power 3, right? So 0 here because there is no value here, 1 here, 0 here, and 1 here. This is the Boolean representation or the binary representation of 10, right? Similarly, so this is what your 10 is represented in binary. What about 4, right? 4 can be represented as 0, 1, 0, 0 because 2 power 2 is 4, right? So this is how you represent it. Now when you say AND, this symbol is a single ampersand, right? When you do it, it does a bitwise AND. So 10 and 4 is, now you do, okay, 0 and 0 is 0, 1 and 0 is of course 0, 0 and 1 is 0, 1 and 0 is 0. So what you should get here as output, you should get 0 as output, and that's what you get. Sorry, that's what you get here, right? Similarly, what about OR? Let's just quickly see that. Okay, let's just quickly see OR here. So when you do OR, you get 14. Why? Because again, simply 10 or 4, 0 or 0 is 0, 1 or 0 is 1, 0 or 1 is 1, 1 and 0 is 1, and this is 14, right? Because 2 power 0, 2 power 1, 2 power 2, 2 power 3, 8 plus 4 plus 2, that's 14, right? Works out. Similarly, you can do all these operations like or not basically does the exact, so basically not of 10 would just say, flip these into 0, 1, 0, 1, right? So these are very simple bitwise operators. Those of you who have studied computer science or have any familiarity with programming languages will quickly understand this. Next comes the interesting assignment operators. Of course, we have seen equal to. So what does this do? It assigns the value of 10 to a, right? Now comes the other interesting operations like plus equals to 10. So those of you who have seen C would easily understand this. Okay, let me scroll up a little. Okay, so a plus or equals to is nothing but, so this is nothing but a equals to a plus 10. So minus equal to is nothing but a equals to a minus 10. Star equal to is nothing but a equals to a multiplied by 10, and so on and so forth. We have seen the floor division, the modulo operator, exponent operator, etc. It's just exactly the same thing. So whenever you have plus and equal to, basically a basic operator and an equal to, this will just unroll it into this format. This is a more concise representation of this statement, except that there is not much difference here. Okay, so those of you who have some familiarity with C would recognize this immediately. So a plus or equal to 10 should be equal to 20, because a already has a value of 10 here. 10 plus 10 plus 10 will be 20, right? So again, very basic stuff here. Now here comes an interesting thing called identity operators in Python. So there are two such operators. One of them is called is and other is called is not, right? So let's say I assign a value of 5 to A. Similarly, I assign a value of 5 to B. Now if I say print A is B, surprisingly you'll get it true. Because what's happening internally is, I think we discussed this in one of our previous videos, there is a memory location where 5 is stored, and A points to it and B also points to the same object, right? So when you say is A, is it true that A is B? Yes, of course it's true, and hence it prints it, right? Now the same thing is not true for lists. So here if you look at it, I have a list L1, which is 1, 2, 3. I also have a list 1, 2, 3. Right? You might say, okay, probably this list 1, 2, 3 is being created in a memory location, and both L1 and L2 are pointing to it. Right? No, this is not true. It's only true for variables like this, for numbers, or for simple variables, not for complex variables like your lists and dictionaries and tuples, more complex data structures. It's not true. Okay, so this returns false for you. What about strings? Even for strings, this is not the same. Even though it's the same string, I have S1 and S2. You might assume that AAIC is a string being created in memory, and S1 is pointing to it and S2 is pointing to it. And that's true. That's exactly how strings work, right? Because here in this, okay, let's just go here. So I told you, right, only for complex data types. So if I run this, I get true. I could say is not, then you get false, right? So even for strings, everything works just like your numbers there, your numbers up here. Okay, only for slightly more complex data types like list, tuples, etc., it doesn't work. There's another very interesting operators in Python called in and not in, which are called membership operators. Let's look at it. Suppose if I have a list LST with 4 numbers 1, 2, 3, 4, I could say 1 in list. If 1 is there in this list, it would return me true. That's what it does. Very useful, right? Because now you can say whether an element is there in a list or not, right? You can do this for strings, for lists, for tuples, dictionaries, sets, etc. So let's do another example, right? Let's say I have a dictionary here. This is a dictionary. This is my key 1, this is my value 1, this is my key 2, this is my value 2. So I can search in the keys very easily. If I say is print 1 in D, since 1 is present in the keys, it would print true. Let's go to this code snippet and see what happens if I say is A in D, right? It says false. I can only check in the keys, not in the values, right? Can I say 2 in D? Of course it's there. What about 3 in D? Of course 3 is not there, so it should return as false. So in dictionaries, the in operator is only used to check if a given value is in the keys, in the set of keys. Here this is K1, value 1, K2, value 2. It only works in the keys and not in values, right? That's a membership operator. Flow control statements like if-else. So those of you who know if-else statements in C, C++ or Java, this will look very familiar. There are some simple syntax changes, except that everything should be exactly the way you know it in C or C++, logically speaking at least. So let's look at a very simple statement. So what it does, so this statement does, if you write an expression, I'll show you what an expression is. You write a text expression. If that is true, there is a semicolon at the end here. Sorry, there is a colon at the end. Sorry, not a semicolon. There is a colon at the end. And any statement which is indented, indentation here, just to quickly recap for you, is basically 4 spaces, and that's a good programming habit. Or you could use a tab, but I recommend you to use 4 spaces, right? So everything which is indented will get executed whenever this statement is true. So let's see an example. I think that's what makes it simpler. This is a simple flow chart, but let's look at it from an example. That will make life, and that will make it much easier. Imagine if I declare, if I assign a value of 10 to a variable num, and if I say if num is greater than 10, this is my test condition, right? This is the condition that I'm testing, right? And what is the result of this? Num is not, because num equals 10, this is false. When this is false, it won't run everything that, so this is indented, right? This line is indented, so it won't run this. So the output of this is, this will always print. So what happens is, once the indentation is over, so your if and print are at the same level. This print, the second print and if are at the same level, right? Since they're at the same level, after your indentation, your basically code will run as follows. It will go in this. If this condition is true, it will go in, or else it won't, and then it will continue as soon as the indentation is over, right? So let's just quickly change this and see a few examples. So if I say num double equal to 10, right? Now what should happen? It should print both these lines, right? So yeah, it does print both of them. Similar, so there's a small variation here. Everything which is 0. So what if I just give it 0? For example, if I do num minus 10, num minus 10 is 0, right? Then what happens? 0 is taken as false in Python, right? Every non-zero value, if I put minus 1 here, minus 1 is taken as true, plus 1 is taken as true. Everything is taken as true except 0 and none. So if I give the keyword none, none basically means absence of anything, right? None, and so just to quickly tell you that, so 0, none, and false are considered as false. Everything else is considered as true. So everything else is considered as true when you're evaluating statements, okay, in Python at least. So your minus 1 will become true, right? So this might be slightly different from other programming languages. So this is something to note. The next type of statement, again, let's go through an example. There's a flow chart here and all that, but always looking through examples is better. So what happens in a statement like this? If num is greater than 0, so I'm assigning exactly 10 to num. If num is greater than 0, always remember there is a colon here, unlike other programming languages. People who come from C, C++ do not use this. And see, how do you write this? If num is greater than 0, execute these statements, else execute these statements, right? This is how we write it in C, right? So unlike that, what we do here is, if num is greater than 0, positive number, which means 10 is greater than 0, right? So it will print this, as you would expect. Else, if this is not true, it will print this, right? Very, very simple and straightforward. So there is also a slightly different, people who come from the C world know if and else. So there is also something called elif. Elif is nothing but else if, okay? Elif needs to be read as else if, just for simplicity. So let's see how it works, okay? So if I give a value of, if I give a value of 10.5, a float value to num, and now when I run this, let me just quickly run this for you. I'm trying to run this for you. Small hiccup here. Yes. Yes. I hope I can. Yes. Now we can run it. So we get a value of positive number as soon as I run it. Now if I say, if I declare my num to be 0, what happens? Okay, let's run that. You get a value of 0, because what happened here, right? Your output here is 0 as soon as I ran it. Now what's happening here is, first it will check if number is greater than 0, it's not. Then it will go to else if or elif. Now it will check if number equals to 0. If it is 0, it will print this, and the else won't be printed. It will just go to this line. Whatever line is there after your if, elif, else, right? So elif, if you want to think about it, you should read it as else if, right? So if you have multiple conditions that you need to check in an if else, you could just use this. You could say if condition 1, elif condition 2, elif condition 3, so on and so forth, else is if not any of the above, right? This is how you do this is elif is slightly different from other programming languages. So now let's look at nested if else's. Nested if else's are very, very straightforward. So for example, let's look at it like this. So the same thing that we saw using elif can be written without using elif. So let's see how to write it. I could say if number is greater than or equal to 0. So let's assume my number is 10.5, right? So this condition is true. So remember, all these lines are indented at this. So this whole thing will be executed because of the indentation, right? See, this indentation is longer than this. So this is, whenever you have indentation in C, you can think of it as this. Okay. Of course, it's not explicitly written in Python, but that's if you're coming from a C, C++ or Java world, you can think of this as a block which is surrounded by curly braces. Now, as soon as you come in, now it will check if number equals to 0. If it is 0, yes, it will print 0. Else, it will print positive number. Right? So this is this block of code here is like a regular if else, except that this if else is inside an if. Right? This is called nesting because we have if inside an if, and so we have an if else inside an if. Right? And you can have multiple levels of nesting. You can have nestings like this: if, else. So this is 3-level nesting, right? Because inside an if you have an if, inside an if you have an if, and look at it, right? So as soon as you have this very nice structure of indentation, you'll get the order much more easily instead of you having these blocks. As a good programming practice, even when you're writing code in C, you're asked to put indentation. So if your if condition is here, right, you're asked to put some indentation or gap here so that your code is much more readable. Python forces you to do that as a matter of design, so that your code looks much more crisp and clean and clear. So let's do a very small example, a very, very simple, I would call it toy example. Okay, imagine if you're given 3 numbers and you want to find the largest of the 3 numbers, right? Very, very simple. Let's do it using if, elif, okay? Suppose I have 10, 50 and 15, num1, num2, num3, 3 variables, taking these 3 values. So the logic is like this. If number 1 is greater than number 2, and this is logical and, this is your logical and if number 1 is also greater than number 3, then we know the largest number is num1, right? Else, if both these conditions are not true, then, else, if number 2 is greater than number 1 or greater than equal to, and number 2 is greater than equal to number 3, then your largest number is number 2. If neither number 1 or number 2 are the largest, then of course number 3 is the largest. This is a very, very simple example of using if elifs. And of course, if I run this, you'll get the largest number to be 50, as you would expect. Straightforward. So if else's are very, very important when you want to control how your code is being executed, right? Only when a condition is true, you want a snippet of code to run, right? This is the C syntax, or I've mixed syntax here. Again, if you're programming in multiple languages, it's very, very common to mix up syntaxes. I've been programming in 2 to 3 languages at any given time, typically Python, R, and sometimes Java. So I mix up code like crazy and get errors left and right. But yeah, my preference is always to Python. If you give me an open-ended problem, I would typically try to do it with Python because it's much more elegant, easy, and there are tons of libraries to help me do my work better, right? So yeah, this is simple if else. We'll look at other examples of control flow like while loop, for loop, etc. in the subsequent videos. For those of you who know what a loop is, for those of you who have seen something like a while loop in C, C++, or Java, you'll remember and you'll see that the while loop in Python is very, very similar to the while loop in C, C++, Java, except for some small syntactical changes. Intuitively or logically, it's the same thing. For those of you who don't know what a while loop is, imagine if you have a bunch of code, let's assume these 4 lines of code that you want to run over and over again, which means you want to run them and again you want to go up here, again run them, again go up here and run. If you want to run something over and over again, or iteratively as it's called, then we use loops. Very simple loop is the for loop. Sorry, is the while loop. We'll also see the for loop. So let's go and see some examples to understand why for loops are important. So the syntax is very, very simple. So we have the while. While is a keyword in Python, and we have the text expression, with a colon, just like our if. This is something unique to Python, this column. So whenever the text expression is true, the body of the while loop will be executed and all of it is indented. Just to remind you, indentation, try and do 4 spaces in indentation. That's a good programming habit. Okay, so but remember, this body will only run when the text expression is true. Let's see an example so that there is also a flow chart here for those of you who like to see flow charts, but I always prefer examples typically. So let's go through a simple example. Let's assume I have a list. I'll execute this step by step. Okay, suppose I have a list LST which has 5 elements. This is element 0, element 1, 2, 3, and 4. I want to find the product of all of these numbers. How do I do it? So I'll declare a variable called product and assign it a value of 1, and I'll create a variable index with a value of 0. If to multiply this, let's think about the logic. What if I multiply product with 10, right? I'll get some value. I'll get 10 here. The 10 if I multiply with 20, that which if I multiply with 30, and so on and so forth. So if I have to write it more mathematically, can I write it like this? Can I write it like 1 multiplied by, list of 0 multiplied by list of 1 multiplied by list of 2, so on so forth till list of 4, right? This will give me the product of all the numbers, right? You might ask, why are you putting 1 here? Okay, even if you don't put 1 here, it's okay. So, but intuitively, this is what you're doing. But what we'll do is we'll multiply it with 1, because multiplying it with 1 doesn't change the value. So here you're doing the same operation of multiplication multiple times, right? You're repeating that operation, or you're iterating and doing the same operation over and over. So let's see how to write some simple code for that. Okay, so let's look at it. So first, your interpreter went here, it went here, it went here, then it comes here. Now what is the value of index? Value of index is 0. What is the length of list? 5, because there are 5 elements here. Is 0 less than 5? Yes. So this is called the test condition, right? This is true. So as soon as it's true, it will go inside the while loop. So what's there inside the while loop? So since this is true, it will say product multiplied equal to list of index. What is index? Index is 0. What is list of 0? List of 0 is the 0th element in the list, which is 10. So product multiplied equal to 10, which means now what happens? Now your product becomes 10, because star equal to is nothing but product equals to product into 10, right? Now what happens? Now this line also will be executed. Index plus equals to 1, which means what will happen to index now? Index right now is 0. So index will become 1. Now as soon as index has become 1, now, so your interpreter actually went inside, it ran this. Now this is over. Immediately it will go back and it will go back to the first line. Okay, this is what iteration is. Okay, now what happens? What is the value of index? 1. Is 1 less than 5? Because that's a condition we have to check, right? This is your test condition, right? Yes, it is less. So it will go inside. Now product multiplied equal to list index. What is the value of index now? Index is 1. So list of index is 20. So now product has a value of 10. So 10 star equal to 20. What will that be? Which will make product equals to 10 into 20, which is 200. Now index will now increase by 1. It's called incrementing. Okay, this is called incrementing, or increasing it by 1. So now index will become 2. It will keep, now again your loop will go back to the first line. It will keep doing it till, so let's assume my index becomes 5, because I'm increasing my index with every iteration, right? Imagine index becomes 5 at one point, right? Then what happens? This condition fails. When will that fail? When your product has multiplied with all the numbers till 4, till 50. That's what I meant, till list 4, right? Then what happens is, because this test condition has failed, right? It will not go inside. It will not go inside anymore. It will directly come and try to execute this next line. This next line is empty. So it will come here and execute this. So it will print the value of the product. Okay, so let's just execute it and see what happens. So this is how loops work in most programming languages. Okay, I'm just trying to get this to, okay, so now I have it. Okay, your product is this. Suppose if I just change it, just to show you that I didn't cook it up. Okay, the numbers are changing. Okay, and this is the product of 10, 20, 30, 40, 60. Right? So this is how a while loop looks like, and this is what while loop does internally in most programming languages, and but this is how it does it in Python for sure, as we saw. Now, unlike other languages, there is an interesting part here. Now, what happens if I have a while loop? Just like if else, I can also put an else for while. What happens is whenever this condition fails, this else part will run. This else block will run whenever this condition fails. Right? So, for example, in this condition, in this, what I'm doing here is I'm just printing the numbers in my list called numbers. Okay, so let's try to execute it first. Okay, let's see if it runs properly. Okay, so if I just say, I'm just changing it slightly. So what it's doing, it's basically saying, okay, if you look at the code, of course, with time you'll get used to looking at loops and understanding it immediately. So index basically tells me which index I should be at, right? Now, my index less than length, my length is 5 again, just like the previous case, right? Index is 0, print the number. So it will print 1, 2, 3, 4, 5. At some point, index will become 5 because you're incrementing index here, right? Index will become 5. Now, when it becomes 5, what happens is there will be no more items left, right? Because this condition has failed. 5 is not less than equal to 5 at some point. Okay, after it has print all the numbers, right? Then what it does is interesting. Then it goes and runs whatever is there in the else block before going out of it. Okay, there is one catch that often happens. A lot of times people forget to do this part. One of the biggest reasons. If you forget it, what happens? If you forget it, this is a very interesting thing. Suppose if I forget to print this, if I forget this line, then I'll remove it and show it to you, by the way, programmatically. Then your index is never getting increased, is never getting incremented, right? Which means this loop will keep running, this loop will keep running, this loop will keep running. Such a loop is called an infinite loop. So if you have a program with infinite loop, it will be impossible for you to get out of it. So it will never stop executing. So let's see an example. Let's run this by removing this line. I'm removing this line here. Okay, just to show you, saved it. When I run it, it's continuously running. See this star symbol here. It's running, it's printing. So this star symbol here shows that the program is still running. Okay, of course, we need to kill it, of course, no. So what I'll just do is I'll interrupt. Okay, which means I'm going to say stop this. Okay, see how many values it has printed. It has printed like, because it's continuously doing that. It's printed all these values. So always remember, never ever forget to increment whatever is being iterated on. So index is called the iteration variable because you're iterating on that. You're using it to check, and if you don't increment it, you're in big trouble. If you forget this line, this will keep running infinite times till the time you block it or you stop it explicitly. Okay. Having said that, let's go and see a more real world-ish example. So imagine if I want to write a simple program to check whether a given number is prime or not. Okay, so let's see how to do it. It's very, very simple and straightforward. Okay, first let's run this code so that we know what's happening. Okay, let me just quickly run this. Let's enter a number. Let's assume I enter 19. Okay, it says 19 is a prime number here, right? Let me just highlight that. Okay, it says 19 is a prime number, which is good. So what if I enter a different value? Okay, let me rerun it again. If I enter, let's say 16. Now it tells me that 16 is not a prime number, and it's telling me all the values that 16 is divisible by. 16 is divisible by 2, 4, 8. Just as a quick recap, for those of you who forgot what a prime number is a number which is divisible by itself and 1 and no other number, right? So how do we check it? We basically divide a given number by every number between 2 to n minus 1, given the number is n, right? So let's see. So here I'm just saying, okay, this is your standard input output, right? I just say enter a number, and whatever number is entered here, I'm converting into integer, because real values being prime is ridiculous. It's only integers which can be prime or not, right? So my number is the number that I've input. My num variable has the number that I've physically input, as you saw a while ago. I'm creating a Boolean variable called is divisible. This value will turn to true whenever, suppose my number is 19. What I'll do here is I'll check whether 2 can divide it, whether 3 can divide it, whether 4 can divide it, 5 can divide it, so on and so forth till 18 can divide it. If any of these numbers can divide it, of course 19 will always be divisible by 1 and itself. If any other number can divide 19, so 19 is inside my num, right? Okay, so if any of these numbers can divide it, I'll change is divisible to true. Now at the end I'll say if it is, okay, let's look at the code, right? So before we go and see the loop, let's see what it is. So at the end I'm saying if is divisible, which means if is divisible is true, then say it's not a prime number. If is divisible is false, print that it's a prime number. Okay, so intuitively what am I doing? If you have number is 19, if your num is 19, I'm taking all the values from 2, so on and so forth, 17, 18. And if any of these numbers can divide it, can divide 19 and have a remainder which is 0, then 19 is divisible by all these numbers, right? So here what we have to do, we have to divide 19 by each of these numbers. As soon as you have to do something repeatedly, you have to think, okay, I have to use loops, right? So I've given a variable I as 2, which means my I is here now. My I has a value of 2. And while I is less than num, my num is 19, right? Which means my I, this loop will run. And here I'm saying I equals to I plus 1 at the end of this loop. This whole block is my loop, right? If you think about it. So by looking at these two, you can easily say that this loop will run from I equals to 2. Since I'm incrementing it, next time what happens? I becomes 3. Next time I becomes 4. So on and so forth till 18. As soon as I becomes 19, this condition will fail. Right? So by just looking at the condition and how the variable is incremented, you can say what the loop will run through. It will run from I equals to 2, right? I equals to 3, I equals to 4, so on and so forth, I equals to 17 and I equals to 18. Okay, now what are we doing inside this loop? So we understood the iteration part of it, right? Where is it starting? We know it's starting at 2. We know when it will end. We know what all numbers in between will be iterated through. Now what I'm saying here is if num percentile I, percentage is a symbol which I think we discussed earlier, which gives us the reminder when number is divided by I. So for example, for 19 percentile 2 is when I divide 19 by 2, what is the remainder? The remainder is 1 because 2 9s are 18 and the remainder is 1. So this gives us the remainder. If the remainder is 0, okay, if the remainder is 0, so for example, if my number is 18 percentile 2 is 0 because 2 9s are exactly 18 and the remainder is 0. So this is, you can think of it as a remainder operator, a numerical remainder. Okay, when you divide number with I or num with I. Now when that is 0, you know that your num is divisible by I, which means as soon as you see it, you say, oh yes, you change the is divisible by true and you print that, okay, so and so number is divisible by my I. As soon as you have it true, even if one number other than 1 and the number itself, if any other number can divide it, you say it's not a prime. Exactly, that's what is happening. So it will keep running it. At the end of it, if my is divisible is true, right, then if it is true, which means there was some number between 2 and n minus 1 or num minus 1 that could divide it, and hence I say it's not a prime number. Otherwise, okay, if no number could divide it, I'll say it's a prime number. Very simple code. I strongly recommend you folks go through this in more detail and understand what's happening and try this. I mean, since all these IPython notebooks are at your disposal, I strongly recommend you play with it, right? So we'll see other types of loops and other constructs within loops in the next videos. Keywords and ideas in loops called break and continue. These are super useful. We'll see why they're useful with the prime number example again. So let's see what happens. Let's see how break and continue behave. Okay, here is your flowchart for those of you who like to see flowcharts. This is also a very interesting example. So for example, whether we are in a for loop or in a while loop. Okay, suppose if I say, okay, if I do something like this, if I say at some point, if I say break, Okay, if your interpreter executes break, it will directly come out of your, so this is your for loop body, right? This is the body of your for loop. It will directly come out of your for loop body and execute code which is outside the for loop. Okay. Similarly, for break in if else conditions, in the while loop. So this is the body of your while loop. If you say break, it means come out of the for loop or the while loop. Just come out of your loop structure or break out of your loop structure. That's what it means. Okay. So this is visually very, very interesting. So it tells you as soon as break runs, where does your Python interpreter start running next? So this is code outside the for loop. Similarly, in a while loop, it directly comes outside the while loop. So here it's coming outside the for loop block, right? So let's see an example that will make it much simpler for us. Okay, let's see. So imagine if I have a list of 1, 2, 3, 4 numbers and I'm iterating over the list. I'm saying num in numbers. If number equals to 4, break. Okay, so what will happen first? First, my num will be 1. This condition is not true, so it will print. So it has print 1. Now 2. That's what it's iterating, right? Now my num becomes 2. Now my num was 1. Now it will become num equals to 2. Is 2 equal to 4? No. So it will just print this. So if it's not true, this is the if condition, right? It will not go into this, right? So print num, it will print. Similarly for 3. As soon as num becomes 4, if num equals to 4, break. Which means it ran this, num equals to 4, true. It comes here. As soon as it sees break, it will say, oh, this whole thing is my for loop, right? For with an else here. This is important. So it will directly come outside the for loop and print, and it will start executing from this line, right? See, it is also skipped the else. That's important. It has also skipped the else part in your for loop. Okay, it's directly come to outside the loop because it looks at this whole thing as one logical chunk. Okay, so break is very useful. Let's see an example for the Python for the program to detect whether a number is prime or not. Right? We saw this example, right? We saw this example where I'm making only one change here. I'm making one simple change here, nothing else. I'm just putting a break here. So what am I doing? If a number is divisible, right? If let's say I enter, let's say 16. Okay, let's assume my number is 16. Okay, I'm iterating this from 2 to 15, right? This is what I'm iterating, right? Because I equals to 2, I less than equals to num, and I'm incrementing I by 1. Okay, which means I got 2, 3, 4, so on, so forth, 15. Now, 16 percentile 2 is 0. As soon as that becomes 0, I'm saying is divisible equals to true, and I'm printing that, okay, so and so number is divisible by so and so number, and I'm saying break. So as soon as break happens, what happens? Now this is my while loop, right? I'm going to come out of my while loop and print it. What's happening here is earlier we were checking all the numbers 2, 3, 4, 5, so on, so forth till 15, right? Which means we are actually doing this, we are running this loop 14 times because there are 14 elements here, right? 1, 2, 3, 4, so on, so forth, right? If you count number of elements here, there are 14 elements. 15 minus 2 plus 1, right? There are 14 elements here. But by using the break, as soon as I find any number which divides it, I'm saying come out because I know it's not a prime anymore, right? So by using break, instead of running this loop 14 times, okay, if your num equals to 16, that's what I'm assuming here. If your num equals to 16, okay, you're going to run this loop 14 times. Instead of doing that, as soon as I find some number which can exactly divide your num, come out of the loop and say it's not a prime number. This is much more efficient, right? Because instead of running it 14 times every time, as soon as I find a number, I'm going to come out of it. Okay, of course, I might find it at the start, or I might find it at the middle, or I might find it almost at the end. That doesn't matter. But break is making your code much more efficient, where it's saying, okay, don't run through this loop 14 times. Just run through it as long as you don't find a number which can exactly divide it. Which means it's improving the number of times you run your loop. By the way, for a lot of programs in modern computing, a lot of time is actually spent in loops. So almost 80% of your code typically spends time in 20% of your code, which is mostly your for loop code. 80% of the time is spent here in loops like this, right? So if you can reduce the number of iterations by using break, you're making the time that it takes to run this program much lower, right? So let's just quickly run this so that there are no syntactical errors. Sorry. Okay, so here is the code. Let's run this. Okay, so if I enter 19, what's happening? It's saying it's a prime number. If I enter, let's say 16, what happens? Oh, it says it's not divisible by, it's divisible by 2. So it's just taking the first one. It's saying it's divisible by 2, and hence it's not a prime number. I don't care if 4, 8 other numbers also can divide. I don't really give a damn about it. Okay, because it's divisible by 2, I'm going to come out and say it's not a prime number. Okay, this is where break is extremely useful, where you want to come out of it for efficiency reasons. There is another type of construct or keyword called continue. Let's see what happens in continue. Instead of the flow chart, I'll take you through this very interesting example. So what continue does is very, very interesting. So for example, if as soon as your code goes and runs continue code, runs the line which has the keyword continue, instead of so break takes you out of the loop, right? This is the structure of the loop, right? This is the block where your for loop is executing, and this is the block where your while loop is executing. What did break do? Break took us out of the loop. Continue will take you to the next iteration of the loop. It will not execute anything here. It will not execute anything that is after the continue. It will directly take you to the next iteration in the loop. So it says continue running the loop without running anything which is below me, if you want to remember it that way. Continue the loop. Okay, let's look at here. Okay, suppose if I want, this is actually a very, very simple example. If I want to print only odd numbers, okay, so I'll say for num in numbers, which means it will go through all of them. If number percentile 2 equals to 0, continue. So what happens with 1? 1 percentile 2 is 1, not equal to 0. So it will never come into this continue. It will print the number. It is print 1 here. Okay. Now next, see what happens for 2 when num equals to 2. When num equals to 2, 2 percentile 2 equals to 0. So it will say continue. As soon as it continues, it will go here. It will now take your num to 3, which means it has not printed this, right? So that's why in the output, you don't see 2 here, right? You want to print only the odd numbers in the list, isn't it? So whenever this condition is satisfied, whenever it's an even number, continue. Don't run this line, because this whole block is your for loop, right? But what happens is after all the loops are over, it will still go and print the else loop. It'll go and execute the else block. So it went through 1, 3, 5, and it's running the else block. Remember, your break even comes out of the else part. We saw that earlier, right, in this example. So in this example, as soon as you said break, it didn't even print this line. It directly came and print this line. So break takes you outside even the else part. Continue on the other hand takes you up. Instead of taking you out of the loop, continue will take you back to this part, and it says, okay, don't run anything which is below me. Okay, just go up and keep doing it. And after everything is over, else will run as is, right? That's a simple example. So break and continue are extremely important constructs in your loops. So today in these discussions, in the sequence of last 3 discussions or last 3 talks, we went through what a while loop is, we went through what a for loop is, and we went and understood what is break and continue. These are extremely useful constructs in any major programming language, and Python makes it much more elegant and simple and easy to write, especially through ideas like indentation and simpler syntax with the keyword in here.